All right. Well, good evening, everybody. Welcome. Glad you guys are all here for our September meeting. For those of you who don't know me, my name is Mark Menerich. I'm the president of the astronomy section. And we are meeting both here at the Ferris Center. And I think we have 2, 4, 6, 8, 10, 12, 14, 15, 16 people here. We got another 8+ online, 24 or so people. So welcome everybody to our September meeting. Glad you guys can make it. And can everybody see my presentation online? Hope you guys can see it. All right, excellent. So I started out tonight with an image from the latest image from the James Webb Space Telescope. This is the latest one they've sent out. This is a multiple camera image of the Tarantula Nebula down in the southern hemisphere. I think this is part of Eta Carina. And this is a star forming region. Absolutely phenomenal detail we're getting. I'm not even doing it justice here because this is a lower res version of it. And I chose this as my background tonight. So all those stuff that you'll see. So this is kind of dimmed it, but in our background tonight. So here we go. Right. And trying to advance my slides. There we go. All right. All right. So welcome to the September meeting. Tonight we'll have some announcements, some welcoming stuff here, and then our featured talk is by Conrad Wells, formerly of L3 Harris. He was on the JWST design team, and he actually called me today. He said he wanted to change his talk. There's so many cool things that have been happening with James Webb. He wants to talk about some of the things that it's doing rather than some of the science on it. So we'll see what's happening with that when Steve gets up. I'm certain if you have any questions as to what's happening, how things happen with James Webb, how it was assembled, some of the thoughts they made, I'm sure he'll answer some of those as well. All right, so is there anybody that has never been to an ASRAS astronomy section meeting before? Put up your hand if you've never been to it. Thank you. Thank you for coming. Appreciate you guys coming. If I could ask, what prompted you to come today? You came because Devin dragged you here, right? Okay. And your name is? Daniel. Daniel, thanks for coming, Daniel. Thanks for dragging him down here, Devin. Awesome. And you are? I'm Alan. Alan? And I found out from friends. You found out from friends. Friends that belong here, friends that visited here. Yeah. Awesome. So you had a lifelong interest in astronomy or just a recent interest? Awesome. Well, welcome. Thanks for coming. I hope you enjoy your time here. And we'll definitely be able to do some observing time, looks like. All right, so speaking of observing, anybody want to talk about some observing? I have some images up here to prompt people to talk. Doug Kostic took this image just a few days ago of a huge filament and a very active area on the sun. You want to talk about it a little bit, Douglas?
Yeah, that was last Saturday. It was midday. I wasn't planning on doing any images. It was cloudy.
Yeah.
But it was now taking 6 months, 8 months, a year, and they held up hundreds.
Go ahead.
We were having some issues with the mounts and the controller recently, and then Bob put a new hand controller on it, and it was even worse.
Oh dear.
That. So I came over to try and get the computer to control it properly to do aiming. So that's what I was working on mainly. But while I was inside with the roof on, I noticed it was starting to get a little bit clear. It was still a little cloudy, so it's like, okay, well, to tell if it's working well and tracking well, I'll just point it at the sun. Focusing was a little tricky because I was looking through the clouds, thin clouds.
Yeah. But
I spent enough time focusing, and that's the key. If you really get a good focus, you can process a nice image out of it.
That's a beautiful image.
That was 500 images stacked.
So that's a video, the video stack. Awesome. That's a beautiful image.
How long? Span of video? What's the window? How much movement?
Can you guys hear what's happening in here?
Don't sit still.
So it was, I don't know, maybe 40 seconds or so. The exposures are short.
Oh yeah. That's what I expected.
About 40 seconds in it. You guys able to hear some of this? Okay, good.
So effectively, as much as still as you can do.
Yeah. Kevin Lyons took a picture of Jupiter, and he's been out like every night, I think, imaging. So you're seeing in your mail, if you're on our Gmail list, and that's an advantage of becoming a member. You can ask to join our Google groups, and you'll see stuff that members are imaging, other conversations about going out to observe on certain nights, or other astrophotography stuff, or just visual stuff, plans to gather. If you're join that Google groups and you're in that. So Kevin's been sending out these images. This was his latest one of Jupiter a few days ago. He just, in fact, today, I think he sent one out of Saturn. It was absolutely stunning. So that was awesome. And then I put one down that Nick had on his website. I stole it from Nick. I didn't ask for any permission, but I knew you wouldn't mind. Because I know Nick did some observing about a week ago, because I was there with him. How was that?
Awesome. Was it?
Yes.
Cherry Springs State Park. Incredible. Went down this one night. Incredible stuff.
Is that from Cherry Springs?
Yes,
Yeah,
Cherry Springs.
yeah.
Those are just, that's just a stitch, panel stitch of 3 single 1 minute photos. It's incredible. I mean, it got dark. The Milky Way just jumped out. You could, I mean, naked eye.
Without the red of the hydrogen alpha, this is what you see when you're darkened out.
Yeah. Yeah. It's
The summer Milky Ways.
Yeah, it's not that colorful with your naked eye, because your eyes pick up all that color, but you'll see if that was in black and white, that's pretty much what you'd see down at Cherry Springs. It's dark.
When it gets
David.
dark,
We had an open house about 2 weeks ago,
A couple weeks ago.
and we had an open house in public. And Saturday night, we had a members open house. We were there.
Yeah.
But Jupiter was rising, and I could see glimpses of it through the trees. So I took the cave and I pointed the cave at the trees. And the trees work as a Notre-Dame filter.
Very good.
And you got these really cool images of Jupiter.
That's
from the
awesome.
trees.
Yeah, because it blocked because Jupiter is really bright. You'll look at Jupiter later tonight if you're here. And Jupiter is very, very bright. You have to knock it down. It's so bright. So that'd be a cool thing.
Everyone's asking, like, what is that?
Yeah, it's so bright. Any other observing stories? Well, hopefully we can tell some more after tonight. So thanks for sharing those, guys.
Well, yeah, I did. I went up to the Adirondacks.
Yeah.
And just like with the binoculars, so everybody else kind of went to bed and just sat out on the
Oh.
porch. I was like, I can't leave, not with a skylight.
No.
I just like kind of sat there, just kind of going from one little fuzzy blurry to the next. I had no idea really what I was looking at, because I only had a piece of this done. But Doug actually, I had no internet, so I couldn't like look at any of my star charts or anything
Sure.
to see what I was looking at. So I was texting though with Doug, and he sent me some like pictures of like some star maps. But that was just really such a treat.
Oh, that's
Great.
awesome. That's awesome. We have had some nice nights, and it's nice when it's warm out to be able to do that too.
Gorgeous.
Yeah. All right, so here's some upcoming events. I got a whole bunch of upcoming stuff, and then we'll get into our talk. So we are back to observing and actually staffing the telescopes at the Strasbourg Planetarium. Here's the dates and times that get us through the beginning of October. We're actually going to be there right through the middle of December, not during Thanksgiving week and not during Christmas at the end of the year, because that's just too many other things going on with those holidays. But in September from 8 to 9:30, if you want to go to observe or help out with people that climb those 61 stairs to go up to see this, the 12-inch scope. Don's one of the regular guys there. How many people did you have out there last week?
About 75.
So it's a lot of people.
Kind of.
It's overtime, but you can get
Yeah.
75 people. And so we could use help with people, especially at the end of the night, because we're cutting it off at 9:30. They want us out of there by 10. So we got to cut off our line at 9:30. We need somebody actually down there to cut it off at 9:30 so that we're all done. And then get everybody up there and then get everybody down and lock it up. And we're done for the night. But it's worthwhile to look through a 12-inch scope. We also have the Schmidt-Cassegrain scope up there for some deep sky stuff. But really right now, the moon and the planets is what we're focused on. Anything else, Dan?
Something that helps us down there is to have somebody that's not operating scopes to just kind of talk to the groups of people there right now, point out the summer triangle and things of that nature. that helps in a good deal, on there. If anybody, you're welcome to come down and help out in that fashion.
Yeah, so every Saturday, right through, actually, we'll be right through the end of December. I'll put this out again in October, but certainly every weekend right now through the beginning of October. Come on out.
Mark, it's very simple to schedule. We're opening at 8 o'clock in September, 7 o'clock in October, November, and through December 17th.
Awesome.
We say we close at 9:30 because we literally have to close at 10. So, expect to be there till 10, but we were not encouraging people to walk up the stairs 10 minutes before 10. So,
Excellent. Thanks, Jim.
and we
Question?
definitely need more help. If you want to learn how to run the scope and help, come up a little early. Don't come up once it gets real busy. Then we get kind of overwhelmed. We don't have time to work with you. Come on up at half an hour early and we'll show you how to open scopes and we can chat.
Sounds good. Thanks, Jim. All right, so we have an open house this Sunday, day after tomorrow. Join us here if you want to explore the facilities. You want to learn how to use some of the equipment that's here, telescopes. There's always some kind of maintenance activity going on here, whether it's painting, repairing something, mowing the lawn, trimming something. So glad to have you here on an open house day. David?
We also have a staff troop back here as well.
Excellent. We'll put them to work too.
Staying from Sunday, from Saturday?
Yes.
Do what you gotta do.
All right, now we have some more public observing happening. This next public observing is Friday, September 23rd. I've hosted the last two. David will be hosting this one. I'll be out of town at a class reunion that weekend, so I won't be here for that one. But this will be our fourth one. The first three, we've had about 30 people at each of them. In fact, the last one, we thought it was going to be a cloud out, and the skies opened up. We ended up having a really nice night, and then it clouded right back up just before 11 o'clock. So we were able to get everybody out by 11 o'clock. And we all got to see some stuff in the skies, including an urban STEM group that been coming out for the last 4 years. They just decided that this was the time they were going to come. They didn't even call me until that day. That day, I got a note that we're coming. Oh, great. But then it was like, I don't know if we're coming. It's not, we don't know what the skies are like. We ended up having a really nice group. Craig, did you want to say something?
Well, they had a 16-year-old.
Oh, my goodness.
Yeah, what did I hear from? I mean, he was asking Mark, but Mark couldn't.
There was a 16-year-old there, and we were going very deep into not just dark matter, dark energy. We started talking about string theory, and I was like, I'm out of my depth. I said, but you need to continue to study this stuff.
You need to come
Yes.
remember.
Anybody remember John Davis?
Yeah,
Same thing.
yeah. Yeah.
You never know.
I can get the dark energy, dark matter. You start talking string theory, I can get about this deep, and then I'm way out of my depth. So, but these are great events to come to. These are very informal. We don't enforce the strict star party rules. So these are people that are the first time they're going to see stars in deep sky. We don't make a big deal out of white light. We'll certainly say something, and you don't want lights in your face in that. But we'll talk about the advantages of dark adaptive sight and that. But we don't make a big deal out of it. So, but we do make sure they park down below. Nobody drives up here, so we don't have to use those kind of white lights. But it's a very informal way to have a star party and let people get some really deep sky image visions. Yes, Peter.
Where is it being advertised?
Right now, this is advertised on our Facebook page, and it's in the community. That was called. There's a community focus magazine that comes out to West Bloomfield, and we will be advertising this even better. Actually, it's also being advertised at the planetarium. They've got a list of telescope opportunities. So the next two star parties, public star parties, are also at the planetarium. So appreciate if you guys want to come out and help with that. We do need, the more people we have out there, the more stuff we can do. So if there's two people that know how to open up the two big roll-offs, those are the key ones that can accommodate a lot of people. Then another person can actually go into the big dome. We can actually be streaming stuff from there as well, doing imaging and streaming. It's going to be, we're doing these during dark sky nights. So, excuse me, I gotta get something to drink. So we will be able to do imaging and share that imaging live, especially since it's got a hyperstar on it. It's a very fast imager. We'll be able to share imaging live while we're doing these events as well. So looking forward to that. Keep that on your calendar, September 23rd. The following night is is our member observing. Now, those nights, we want to observe the start party etiquette. So red light only. You want to keep your dark adaptive sight. There will be likely be people that'll be doing some astro imaging. Park down below if you're planning on leaving anytime before midnight. Leave early. Park down below. If you're bringing a scope and stuff, certainly you can set up your scope and park up here. We don't want lights while people are observing or imaging up here on the hill. So park down below. And ask a lot of questions. You don't need to bring a telescope. Just walk around and look through everybody else's scope. Certainly the club scopes we're opening up so everybody can look through. So come on up for a regular start party. That one is September 24th as well. David will also be hosting that one because I won't be here. But I'll be back for the next one. The next event is our board meeting, which is October 5th. We will be meeting virtually or at the University of Rochester Bausch and Lomb building, room 408. That's to be determined. It might be a different room, but I'll let people know. If you want to get involved with the planning and activity stuff that we do, come to a board meeting, see what we do. We can always use people who want to get engaged and do some stuff there. I'll have further information with getting engaged with the club in a minute, but come to a board meeting, see what happens, see what we do. Be glad to have anybody who wants to come join us. So we'll announce those board meetings in our newsletters as well. Our next general meeting will be at RIT at Carlson, 11:25, and we'll also do this. We'll do this virtual as well. There, our speaker is Brendan Curry, Chief of Operations for the Planetary Society. Now, I'm not real familiar with the Planetary Society. Yes. Oh, he has. Okay.
NASA space policy.
NASA space policy. Okay, thank you. I didn't realize that.
And it is a second Friday. Or did you not change the date?
That's a good question. It might be the second. I think it's the second. That's a bad date.
The date is wrong.
Date is wrong.
It's not the ninth, no, it's not the second.
There, it's fixed.
Yeah, no, it's not the second.
What's that?
Friday was the second of September. March is the only month that gets copied the month before.
Hang on. Give me a moment. It's the 7th. Bad dates. Sorry about that, everybody. We'll update it live. It's the 7th. I have it on my calendar that way. I don't know why it's October 7th. Yeah, 7th is the first Friday.
The first Fridays from now on.
I like to remember.
We'll have an open house that weekend as well.
And is that the right thing?
That is the right thing. I think I copied this slide and made the last slide. What happened? Yes.
I've been there.
Yep. All right, another upcoming event. This is in October. I'm bringing this up now because it's going to be really late in October to bring this up then. But we are hosting a telescope Q&A day at the Strasbourg Planetarium. And we do need members to bring scopes to that event. Specifically, I'd like to see people bring 6, 8, 10-inch telescopes, whether it's a Dobsonian, Newtonian, or a Schmidt-Cassegrain scope. Those are the easiest scopes to get started in. So if you want to bring those, if you have one, contact me, let me know that you're interested. We want to bring those scopes. We want to demonstrate them to people because it's about the time people are going to start thinking about Christmas presents. And the last thing I want to see somebody do is to buy a crappy telescope for somebody for Christmas that they'll never use. They get disappointed, really get dejected about the hobby or the interest in astronomy. Let's get them in a decent telescope and explain how it is. We'll also help encourage people to bring their scope if they don't know what they're doing with it, to help them get acclimated to using it. And certainly if they have a scope that they need to repair, we could look at, see what we got to do to help them with that. And even a pair of binoculars is another thing that we could bring as well. Questions about that? That's going to be from 10:30 to 2:30. So certainly if you're interested, we want to show up about 10 o'clock just to get set up.
you setting up the telescopes outside?
But inside, we'll be in the lobby, so you're not gonna be outside, but I think we've done a sneaky thing, like putting a little Saturn way up in the corner of the,
Yeah,
of
it's
the-
more of a fix it than an observer.
yeah,
Well, if the sun's out.
yeah, we could do some solar stuff too.
Usually has Pluto.
Yeah, Pluto, the dog Pluto, not Pluto.
We have a scout troop that day here too. So we'll be people here to observe that stuff.
From Friday night over.
There's another event that the RMSC is hosting at the Cummings Nature Center in Naples. That's the same night as our public observing. Then they're looking for a couple of ASRAS members to support this with telescopes. It's a free event for K through 12 students and their parents, and they're actually providing transportation for people from the city down to Naples to spend a couple hours with telescopes in the sky, and then sending them back up. So this is a real great opportunity to get some urban exposure. People that are in the city don't have that exposure to darker skies, to set up a couple of scopes out there for that family astronomy night that the Rochester Museum of Science Center is doing. Frank.
I've done this before. There is a place in the parking lot where you get a great southern horizon.
Yeah.
You know, you just take the southern trees and walk as far away from them as you can.
This should be a really
If
nice.
we're going for class.
This should be a really nice event for people who never really see the sky, and really don't have the ability to come out to see that sky. They're going to get shipped out there. They're going to be able to get a free ride back and forth. And they'll be the way the rides are going to work. They're going to have staggered bus trips coming back and forth all the way through. I'm looking
And
forward.
they're gonna have other stuff going on.
Yeah, they'll have lots of other stuff going on as well.
Where you want to set your telescopes up is nowhere near any of them. So
Awesome.
it's its own event.
So throwing a lot at you. If you want to see what's going on, that's our website, rochesterastronomy.org. There's an events calendar on there, just updated. We had some issues with our website. It's a lot of the problem stuff is gone. The event calendar looks funky. There's some graphic stuff I got to fix on it yet. But all the events I just showed you are there. Most of the events I showed you are there. So if you want any more information, check the website. You'll be able to get a lot of that information on the site. What's that?
So it's back up.
Yeah, it's back up and clean. All right, so I want to announce something new. Up on the table here, I have a whole bunch of paper pages. You don't have to run up here now to do this, but we met as a committee earlier this week, and there's a bunch of people on the committee, and we meet virtually, we'll meet in person, we do a lot of lifting to get the jobs done around here. But what we've decided we want to do to make sure that everybody can get involved is form committees in very specific areas and encourage people to join these committees to help out. Let us know your interest in these areas in order to just work the facility, work the astronomy, work with the events that you're interested in. So these are some of them. Strassenberg Telescope Observing. Jim leads that group. He's got a good group of people. And as you heard, Jim, you can always use more people. I have a sign-up sheet here for Strassenberg. If you're interested, put your contact information on there. I'll make sure that the people, Jim and his crew, know that you're interested, and they'll contact you to join them. For outreach and public observing, that's a big area. Outreach can include the scouts observing that Dave and Joe do a lot of. If you want to help out with that, glad to have you help out with that. But we do other stuff as well. We've kind of suspended what we were doing with the Rochester City Schools, but I think we can get back into that probably before the end of the year, getting back into the Rochester City Schools. So that's something you're interested in, sign up for that. The public observing nights, you saw I promoted those. If that's something you want to be a regular participant in, there's a sheet for that. Program planning, Dave does a lot of the program planning, in fact, almost all of it. And that's getting our speakers. But if you want to be involved with that, there's a sheet for that. We participate in a couple of festivals, the Fall Festival and the Winter Festival. I don't know if I got a slide for you, but give me a second. Rochester Star Fest, the event we had in July. I'm going to pull you right after this time. Rochester Star Fest is a big event that we have here in the summertime. And we generally, Lori England does a bang up job of coordinating that. Can always use more people coordinating and handling some of the activities that are done around Rochester Star Fest. There's a lot of things. It's not just food. There's talks. There's preparing the site. There's Frank has been our barbecue chef for the last decade or so, or beyond that, 20 years. Telescope Day at the ASRAS, if you want to get involved with that, maybe helping to coordinate that. Holiday extravaganza at the ASRAS, and that's a big event coming up in the first Friday in December. We'll bring a snack to share. We'll have our meeting. We'll have a star show. We'll have member images on the dome and possibly a talk as well. It's a lot of fun during the holiday season. The Ferris Center, that's stuff we do here. It's maintenance here. It's work here. It's coordinating stuff that's going on here. And then finally, we're going to need to form very shortly an Eclipse team. That is a big deal in April 2024. Now, there is a regional Eclipse team that meets right now, that we're meeting in another 2 weeks with the Rochester Museum and Science Center is taking the lead on that. Absolutely. Yeah, there's gonna be a lot of stuff going on, but it goes right through Cheektowaga and it's gonna come right through Rochester as well. So. Yes, thank you. So I put sign-up sheets up here. You don't need to run up here right now to do it, but at some point tonight, if you're interested in any of these activities, come up here and let us know that you're interested in it.
Look at Frank.
Frank's all in. All right, so I have to say a big thank you to everybody. I've been your president for the last 5 years, and I am going to step down from that position in 2023. And so we've been meeting as a board, trying to figure out how we're gonna make the next, find the next president to come in. But I need to say that I have thoroughly enjoyed this job. I love coming up here talking. I love astronomy. I love leading groups of people around the site. But I have opportunities in front of me that I can't pass on. And I am certainly not going anywhere. I will still be on the board. Our board bylaws have the past president serve on the board as a voting member. So I'm not like I'm going anywhere. I'm just not going to be up here every week or every month for you guys. So, but it's a tear-jerking thing to me. It's a little emotional. I've really enjoyed it, and you never know, I might come back. So, but I have an opportunity. The biggest reason is I was asked to be the director of summer tours for the Beast Telescope at the University of Rochester, and that's something Carol has done. 15 years? How long have you been doing that, Carol?
21 years.
21 years. Oh, God. Well, I'm not going to be doing it for 21 years. Those are enormous shoes to fill, but I'll be backfilling Carol with the Mies summer tours, and I'm looking forward to doing that and still doing the stuff that we do here all the time. I'm just not going to be up front here and leading the meeting week in, week out. But here's who will be on the board for next month's, or excuse me, in November's election. So there's our slate of candidates. Tony Golombek will be running as president. Dave Bishop's going to remain the vice president. Eric Day is our treasurer. He came in this year. Bob Easterling is doing a bang-up job as treasurer. Vicky is our secretary. Bill Schlein has been a director the last year. He's also director this year. And so Tony, moving from a director's position, Joe Altieri is going to step back into the board. He was a former board member. I think he was a secretary. I think he was a vice president. And his kids are now off in college. And I said, Joe, please, can you come back? And Joe's agreed to come back as a director. So Joe's back. And another director, because we need one more to backfill Bill Rogers, who is a membership chair. We were at a need for another director because he had a director drop out. So I asked Bill if he would join. He joined. And Bill said, Mark, I could leave at any point now. I said, I think he wants to get off. And so Craig has graciously volunteered to run as a director next year. Craig is our membership chair and will also be a director next year as well. So this is our slate of candidates that you'll see in September, or excuse me, in November. All these are voting members on the board, as well as the past president. there are more people on the board that do not vote. So we have a site manager that does a tremendous amount of work. It comes to every meeting that we do. There is Jim Seidelwan is our planetarium Strasbourg scope liaison. He attends various meetings. I'm going to forget people. Craig had been a membership chair, but he'll also membership chair shows up to those meetings. Peter is our editor of our newsletter. He comes to our meetings.
Master of the newsletter has everybody.
Yep.
So if you wonder.
Yeah, so there is a whole list of people that come to these meetings. And we're glad to have anybody else that wants to join us. The more hands, the lighter the load is. So congratulations to these people that we will vote by a communist slate on November 4th. It'll be you vote for this person or you write somebody in or whatever. So we try not to have any problems that way.
Mark,
Yes.
thank you for the work you've been doing.
Thank you, Peter. Thank you. I enjoyed every minute of it. Every minute of it. All right, so now we're ready for our feature presentation. So I will stop sharing. Conrad, I'm gonna see if I can get your photo over here so everybody can see you. I'll stop
I'm
sharing.
here.
All right.
Great. Can you hear me?
Yes, I can hear you.
Okay, great. Well, it's great to join you guys. I probably should have been a member for years when I lived in Rochester, but c'est la vie. Okay, so let me share my screen here. Okay. So I did jigger this a little bit. I was going to talk about the integration and test of it, because that's really what I was involved in. I'm an optical engineer. I'm not an astrophysicist, but I will say that in the almost 20 years of working on JWST, I certainly learned a lot. And I'm fortunate that I'm good friends with John Mather, the JWST chief scientist, and he shared a chart set with me today that he's giving at the Smithsonian Space Museum this weekend, I guess. So I'm going to talk about my experience on JWST very briefly, and then go into his charts. So that's pretty much what I've said already. That's my summary. So my history. I joined Kodak in 2003 when the program had just begun. I stayed with it until I just left L3 Harris earlier this year. So I went through the whole Kodak, ITT, IT, Excelis, and actually when this chart was written, it was Harris, and now it's L3 Harris. So I was a member of a team of, about 15 optical engineers and technicians and 15 mechanical engineers and technicians. Great group of people. You probably know a lot of them. So our job at Kodak, or finally L3 Harris, was we were going to put the telescope together. We were very good at building and aligning telescopes, and we were known for testing. So it was our job to put the telescope together. You make a winning team with more contractors and spread the money around the country, right? And then we also had to make sure it worked right. That was our responsibility. So taking it to Johnson Space Center, which is the picture you see right here, and we used a large vacuum chamber at JSC to test it. So it was many years. I started as a junior engineer and ended the program 17 years later as the deputy test director. So, spent many years developing the optical metrology to align, build, and test the telescope. So, the first question, how do you assemble a $10 billion? It was funny when I looked at this chart, it said an $8 billion telescope, and then it became 10. Of course, it started at 3 or 5, depending upon when you want to say it. But how do you do that? You got to be really careful, right? You need really good planning. You need, laser metrology and amazing, really good technicians. I mean, that is really, the reason we build such good telescopes is because of the technicians that we have in Rochester, right? I mean, those guys and women that do that work are amazing, and they really deserve a lot of the credit. And a lot of the times they don't get it. So we use laser trackers, right? And pretty amazing stuff, right? You can measure the location. We were able to measure the location of each one of these mirrors. This was a 2-segment test bed that we built as a practice to build, to build the telescope. And of course you practice. And we did have a robotic arm, which was a big help. But we were able to measure the location of each of these mirror to about a human hair, right? 100 microns, or about 4,000ths of an inch. And we shimmed each one, right? We knew where they were to about 100, but we shimmed them into place to about 0.5 millimeter, right? A mechanical pencil lead, right? So this 6.5 meter telescope, we built it, to about 0.5 millimeter. And this shows some of the work. While they built the telescope, we actually had covers on all the mirrors. So you didn't actually see the mirrors until, these 2 technicians from Rochester, very carefully pulled those off, sitting there on diving boards over the mirrors themselves. So, and then this is what it looked like at the end after they took off. That's the exact location where they were removing those covers. So we spent about 4 months putting the mirrors into place, something like that. We practiced it for about a year, and it went together quite well. The second thing that we were responsible for was the cryogenic system level test of the telescope. You may recall, the Hubble Space Telescope did not have a system level test, and it was essential for NASA that there be a system level test. And it was our responsibility to develop with the entire team, right, to design that test and execute that test, right? And we did that successfully, right? When the telescope launched, we knew that optically it was going to work, right? The question was it going to deploy? Was the launch going to be successful? And as we now know, everything went incredibly well. And so it's I didn't relax until it was fully aligned. So what were the goals of that testing? We had to bring the telescope cold, right? We had to bring it down to about 40 Kelvin, minus 370 degrees Fahrenheit, to make sure everything worked correctly, right? The telescope, individual segments had been tested at that temperature. Certain portions of the composite had been tested at that temperature. The science instruments had been tested at that temperature, but put it all together and make sure that it still worked. And each of the mirrors had been tested, but they'd never been aligned all together. So that was a major goal, right? And we did that to an accuracy of like 1/2500th of a human hair. About, we aligned the mirrors to about 30 nanometers or so, with an uncertainty of about 10 nanometers. So, it was our responsibility to make sure we didn't have a Hubble-like error. And part of that is that this was an independent test performed by a quasi-independent contractor, right? Ball Aerospace designed the optics and built the optics and tested the optics. But then you get somebody else to do the system level test that really creates the kind of cross checks. It gets rid of any conflicts of interests that happens, and that happened on the Hubble. So Hubble was very vertically oriented. One company did it all. And in this case, they went and had a team of people. And then to make sure that the instruments were working correctly with light going through the entire system, we illuminated the science instruments with simulated starlight, basically some fibers at an intermediate focal plane. And so are the science instruments working correctly, and are they aligned correctly? So this shows a couple of the pictures. This the Chamber A at Johnson Space Center. This shows just a portion of it, right? It's actually 20 meters in diameter and 37 meters tall. It's got a 24-foot diameter door. This shows a picture of the Apollo service module, I believe, or engineering module. I forget which, but that was put inside the chamber. And actually they put astronauts inside that at cryogenic vacuum temperatures. So it's no longer a man-rated chamber. And this is a picture of the JWST being loaded onto a big stainless steel frame that held it when it was rolled into the chamber. You know, the chamber was heavily refurbished. It had a brand new helium shroud, which got down to 13 degrees Kelvin, a new clean room, and an elegant test architecture. So this shows an image while they're working on it, and you can kind of see the size of a person, right? Pretty small compared to the telescope. This is the telescope loaded into the chamber and getting it ready, hooking everything up and getting it ready for the test. So normally I go through a lot more of the details, but I'm going to do more about the science today. But the test configuration utilized interferometry, right? We had a null lens up at the top of the chamber that illuminated the primary mirror with a multi-wavelength interferometer, allowing us to measure each of these mirrors with respect to the others and aligning them down to, to nanometer levels. We had photogrammetry. There were a series of cameras inside the chamber that looked at retroreflective dots. And I have to admit, photogrammetry is really an amazing technology. We were able to measure the position of any photogrammetric dot with respect to any other photogrammetric dot to numbers like 50 microns at cryogenic temperatures. It was really, really quite amazing. And then, as I mentioned, a series of fiber sources to simulate starlight. So that kind of shows, that gives you an idea of how large this chamber is with the telescope suspended from above on vibration isolators. So I'm happy to have a great set of charts that John Mather put together. As he says, on behalf of the, 8 billion humans, about 10,000 future observers, 20,000 engineers and technicians, and about 100 scientists worldwide, as well as 3 space agencies, right? JWST was a combination of NASA, the European Space Agency, and the Canadian Space Agency. Let me do one thing here. There we go. Okay. Edwin Hubble, made these measurements of, distance and the velocity that things are moving away. And that basically, as you go further away, objects are accelerating away from you. Right. And so John Mather actually is a Nobel laureate for his work on the COBE spacecraft. And this is the cosmic background, the microwave background. And there was a prediction for the amount of, a prediction for the size of these little speckles and how large they would be with respect to each other. And it met the predicted theory that there is still microwave background from about 300,000 years after the Big Bang. And the Hubble is still working, right? The Hubble is 32 years old and it's working well, right? But we're on to a new era here. The Ariane 5 launch was so successful. Their insertion burn was nearly perfect. And as a result, the budget for the amount of fuel that was being saved for JWST during orbiting, they saved a lot of fuel. And as a result, they're hoping for about 20 years of life. You may know that it's not in Earth orbit. So this shows the Earth that goes around the sun. The moon goes around the Earth, and then JWST is at this second Lagrange point, which is a stable point around that. And so that's where I think it's about 5 million miles from Earth. And that's where it lives right now. This shows, many of you have probably seen this animation. It shows the fairly complex animation, right? A fairly complex, exceptionally complex, deployment of this telescope. In order to keep the telescope cool, it has a very large sun shield to keep the heat from the sun and the Earth away from the telescope. The telescope cools itself to about 40 Kelvin using the 3-degree Kelvin background of space to cool it. And so this shows how the mechanics of the deployment occurred, right? The 5 layers, there's a number of, in this region that they're showing right here, it's hot on the bottom and cold on top. And that's a very important region there, right by the post that connects the two, which the name I can't remember at the moment. But they had to deploy all these layers. These layers are actually angled appropriately with respect to each other to channel heat out of the telescope. That shows the secondary mirror unfolding and the 2 primary mirror wings. Many of you have probably seen that already. It worked. That's the amazing thing. There were something like 162 single point failures that could have occurred. And we're all very happy to say that there weren't any. So the telescope works, as I mentioned, there's a hot side, right, which is facing the sun and the Earth, and then there's a cold side, and light comes in. So in this case, the telescope is looking to the right, and light goes off the secondary mirror into the instruments. And why are we observing in the infrared? If we take a look at this is a Hubble image, and that's a JWST image. So one of the biggest reasons, one of the reasons is to see through opaque clouds of dust, right? So if we look, there it is with the Hubble, there it is with the James Webb, right? The second region is to see cool objects. So for example, in this image, this is with the near cam and then the mid infrared on the right. And in the mid infrared, you actually see that this is 2 stars, not 1. And I guess that's a cool red object, and the MIRI has the light, has the right wavelength to see that. And the other reason is that because space is expanding, there's a effect that basically the Doppler effect, as something is moving away, the effective wavelength of the light, when it reaches you, it's actually changed color, right? It's become red shifted. And the further away the object is, the further the red shift. Okay. How do I get to the next slide? There we go. So, light, all the light from these stars left, basically in the visible, right? But then by the time it gets to us, if it's a very distant, if it's, in galaxies far away or, very far away, it's shifted into the red. And so we see, things that were in the visible are now in the infrared. This shows the deepest field that's been done so far in the near cam, and what most of these objects are galaxies, not stars, right? This is a star. It's bright enough that we're seeing diffraction from the mirror petals, but we're seeing micro lensing or lensing, gravitational lensing, I mean. These and we're able to show that they were the same galaxy. So what is a spectrum? We see that, we have the gamma ray, X-ray, ultraviolet, visible, the infrared, microwave, and then radio. And the James Webb Space Telescope is in this infrared region. The Hubble Space Telescope was a UV visible instrument. So, oh, here's that image. So in that image that I showed previously, by looking at these two galaxies, okay, and looking at the spectrum, right, they were able to tell that those were actually the same galaxies that were experiencing gravitational lensing. And you're also able to tell, this shows how an object that was 11 billion years, 11 billion light years away, 12 billion light years away, and 13 and 13.1 billion light years away are red shifted, right? So you see, this light is occurring, the same basic spectrums are occurring, but they're being shifted out into longer wavelengths. And that's why it's so important to have an infrared instrument. For example, then we can look at these a galaxy as a whole, right? We're not able to resolve an individual star in that galaxy, but we can take a look at the composition of the gases that are in general in that, on average, the ensemble in that galaxy, and try to understand how it's changed over time, an older galaxy versus a newer galaxy. So this shows something called Stephan's quintet. One of these is a nearby galaxy, and then 4 of them are much further away, including this special one here that we're gonna, I think, talk about in a moment. So we were, there's a black hole in that region, and we're able to look at the different gas composition around that region, right? And this is done with the near IFU spectroscopy instrument, and looking at that at different wavelengths. And then we're furthermore, right, we can look into that even more, right? Looking at it. So I mean, they're going to do science on this. I can't say that I understand what this means, but what you're seeing is that in the middle versus the edge, there's quite a different change in composition. The Cartwheel galaxy, I think what has happened here is this collided with another galaxy at some point, and that was such a violent event that it blew off a lot of dust. And what we're seeing, what we're seeing is the birth of stars in these outer regions. This is an interesting image, and I guess the blank regions that you see are where stars have formed, and there was an accretion of the dust, right? So the dust isn't there anymore, and it's become, that's why this has this mottled look. And interestingly, this woman, Judy Schmidt, she's a citizen scientist. The JWST images are uploaded, and she processes them and creates some really beautiful images. This is a Carina Nebula, and a region of hot stars vaporizing, birth cloud, and hundreds of new stars forming in these cloud regions, and with interesting shapes, and there's going to be science about all of that, right? So we see here in this region at different wavelengths, right, that there's a whole bunch of stars being born in this region. I think much like what the Orion image on JWST discovered a lot of that, I believe, too. And so we get in, some of the very densest regions, we're seeing, stars forming. The Southern Ring Planetary Nebula, right, having 2 wavelengths, right? We see in this case, in the longer wavelength, that there are 2 stars, not 1. So it's also, there's a variety of science that's done, even looking at our own solar system, right? And the web will be able to image planets in our own solar system from Mars outward. We can't go inside of Mars because you'd be looking too close to the sun and you would damage the telescope. But it has the ability to create pretty amazing images of, in this case, Jupiter. And this was, again, Judy Schmidt did the processing on this. This shows some of the ways that planets are found. So this is a transit method for finding a planet. And in this case, what's going on is transit spectroscopy. Okay, so if the atmosphere is large enough, right? If it's a big gas planet, for example, by looking at the reduction in signal right at the edge, right? You get different signals, right? So using this transit spectroscopy technique, they're able to infer what type of gases are in the atmospheres of these planets. Okay, this shows the predicted spectrum of an Earth-sized planet. And it turns out, this is, there's not a lot of contrast here, okay? And what you'll see in the, I think what you'll see in the next couple slides is these plots go up and there's much more, our atmosphere isn't very thick around the planet. And so when you look at something, a Neptune-sized warm gaseous planet, right, you're seeing more differential signal here. These plots are further away from the flat line of the star. So you can infer, different gases in the atmospheres, right? And now you go all the way to a hot Jupiter-sized planet, and these are much easier to observe. This is some data that was recently taken showing, that they were able to take measurements, right? Relatively noisy, right? These are an individual measurement with an uncertainty bar, but they were able to track that there was enough data to show with the ensemble of data that there was water vapor on this hot gas giant exoplanet. So this was the first exoplanet that was imaged with JWST. Actually, that was modeled imagery previously. This shows the star is where they've suppressed, right? This is a coronagraphic image where you suppress the starlight because the star is significantly brighter than the planet. So you need to remove the light of the star using spectroscopy techniques to basically see the planet. So in this case, we see at different wavelengths information about, you can infer information and do spectroscopy on planets. This is a great, I had seen this image previously and I didn't quite understand it until I saw this. So what they're predicting that this is from, right, is that this is a binary star system, and there's it's interacting. One has a smaller orbit and one has a bigger orbit, and as the gravitational fields of these interact with each other, it's blowing off gas from this star, and that's leaving this pattern in space. Something they hadn't really even thought about seeing. So I thought that was a really great animation. Okay, so I know, I think you wanted me to go to 8:30. I could talk about some more things, but first I want to thank the large L3 Harris team of technicians and engineers who made sure the telescope worked correctly, right? And a big thanks to John Mather for sharing the content, the science content that we saw today. Hopefully people could hear me.
Yep. Thanks so much, Conrad. Appreciate it. You have questions for Conrad, anybody? We get some lights on.
Conrad said, did you say 5 million miles? I thought you were just saying more.
Did you say that L2 is 5 million miles away?
I think it's 5 million. Yeah, it's 5. Yeah, I think
So
it's 5
multiply by
million
what I
miles,
said
or
before by 5.
it's 5 times further than the moon, I believe.
So the moon's about 240,000 miles.
So maybe it's a million miles then. I think it's a million miles.
Million miles. About a million miles.
1.5 million, about 1 million miles. Yeah,
1.5
1 million,
million.
not 5.
It's a million miles.
1.5 million kilometers, 1 million miles.
So we were talking about how long it takes a signal to get from Earth to JWST or vice versa. So it would be light travels 186,000 miles a second. It's somewhere over 5 seconds.
Yeah, because it takes 8 minutes from the sun, I believe. So, and it's not nearly that far.
Michael, you have a question?
Have you figured out where Luke Skywalker is hiding?
He wants to know where Luke Skywalker is hiding. He's on Hoth right now. That was a long time ago. Mark?
How many cameras does the JWST have?
The question was, how many cameras does JWST have?
Yeah, let's see. Do I have that other slide set open? Let me open up. So there are 4 main instruments. The near cam, the near infrared camera, the hold on a second here.
Can you share the slides?
The near infrared camera, the MIRI, the mid infrared instrument, the NIRIS, which is a near infrared imaging spectrometer, and 1, 2, 3. And the near spec, the near infrared spectrometer. That's the main spectrometer instrument. And one of the things, let's see if I can get in the slideshow still.
It's still a slideshow, yeah.
This one of the ways that they do the spectroscopy was shown in one of these images here. Okay, so what you see here is that they take the image of a given object and they spread that across. They spread that light across, and so this right here is essentially the spectrum of that planet. And now when you plot it, you see you have this bright spot there. That's this line right there, right? So you take this image. You only capture part of it, and then you put it into a different part of the instrument, or you insert, actually, I think you insert what's a grism, which is a grating prism combination. And when you do that, it spreads the spectrum of the light out. And that's this is the nearest. The near spec is the most highest resolution spectrometer of the instruments.
So how many of those instruments are spectroscopes? How many are like visual cameras?
I think they all do both.
Oh, awesome. So you just put different.
They all, yeah, I think all these are multi-$100 million instruments. Right?
There's a physical grate that gets slip in front of the camera when you want to do spectroscopy. Wow.
Right, exactly. Or it goes through a slightly different path. Exactly. There's a filter wheel. In the case of the, let's see, where did that go? That must have gone here. I'm struggling to get to the other set of charts here. Yeah, the instruments are, I mean, I've tried to, I don't know where, but I've tried to, I've looked up information about the instruments. They are incredibly complex. Like they're pretty simple from a straight imaging perspective. But when you look at all their capabilities, it's really, they're really remarkable.
It's crazy.
I mean, they're
Yeah.
a major cost, the instruments are a major, the instruments, in the case of the Roman Space Telescope, the instruments cost more than the telescope.
Wow. Devin, you had a question?
Conrad, exoplanet hunter, I've been a part of the science group that's been looking for exoplanets for about 2 years, and we've had pretty good discoveries. Myself, not yet, but it's coming. But we had talked about carbon dioxide being detected in one. I didn't really mention anything. Can you say something about carbon dioxide being detected in the exoplanet's atmosphere?
Did you hear that?
Not really.
Okay, so Devin's is a wannabe exoplanet hunter. She hasn't found one yet, but she's planning on it.
I have 4 candidates. It's coming.
Okay, but she wanted to know if carbon dioxide is one of the combinations that's detected with the JWST.
I have no idea.
Okay. Craig?
I have no.
The Adirondack Astronomy Club presentation the other night, 2 of their scientists said that yes.
Yes, that's right.
In fact, they said that if an exoplanet has more than 25% CO2, the only explanation that they know of is life on that planet. That's the only way the carbon dioxide has to get that.
So I don't know if everybody online heard that, but Craig
I
says,
heard that.
you guys hear that all online?
Go.
25% means that there must be some kind of life. So Jeff Carr is in the chat with a question. He says, will JWST spectroscopy allow us to predict relative percentages for atmospheric components, or just detecting the presence with limited information on the abundance? I think we kind of answered that. It's
Yeah, and there's probably, I mean, they're going to learn, until you look at nature, you don't know what nature is, right? Or, until you look at, and now we're looking at it for the first time. So
yeah. Exciting stuff. Frank?
Did you know Gary Matthews?
of course,
I figured you did.
of course.
So do a lot of us.
Yeah, I mean, the team, Gary Matthews, Tom Scores, Tony Whitman, John Spina, Cormac Merle, John Hannon, the names go, Art, and then let's see, there's a guy who built a telescope and has his own little observatory at his house.
Rick Albrecht. Rick?
Pardon me?
Rick Albrecht?
Tom Day.
Or Tom Day?
Tom Day, yep. Tom
Yeah, okay.
Day.
Wow.
Yeah.
That's cool.
No, and you see, Gary did a presentation on everything they knew at the time. Remember? And it was all about how they were going to test it, because it was, I think Kodak had just lost the mirrors. No?
Yeah.
So
Right, yep. We were hoping to build the mirrors, but we did lose those.
that'd be like 20 years ago.
That would be 2004 or 5, yep.
You guys have been out of a while.
Devin,
Yeah.
to answer your question before, there's somebody put a link in there to answer your question. Is there?
I know there was one that
Yeah.
we discovered.
Yeah.
And like you said, there was 2, there's been 2 since JWST.
No, I said 2 of the scientists on this page, because they were talking about what the goals of JST were. And originally exoplanets were not among the list of goals, but for both these scientists now, given what they're able to resolve from exoplanets, life on exoplanets is at the top of the goals.
That's funny.
You guys can join us.
Right, it's
Here's
not a
a brand new
particularly
telescope. We're already changing its goals.
Yeah, it's not a particularly good at finding I mean, it doesn't have a super modern, oh, that's on the wrong page here. Let me bring this, it doesn't have a super modern coronagraph, right? That's what the Roman Space Telescope is supposed to really
That's true.
bring
That's true.
that forward, right? They have a real coronagraph, not that the ones that we have aren't coronagraphs, but it has a modern, significantly better ability to find planets.
Great. That's cool. Other questions? Doug?
What we learned about the micrometeorite.
Oh, did you hear that?
Yeah, so I talked to Gary about that. And then they actually have a pretty good image right online. I mean, it was bigger than anything they anticipated. It was bigger than anything they could have tested, evidently, because they did test somewhere accelerated something into a piece of beryllium. And so it was larger than anything they anticipated. It is a measurable effect, but it does not affect the science. But there is an image online. Maybe I can pull it up.
How big was it, do you know?
Oh, I'm sure it's still very, I mean, most of them are grains of sand.
Right.
So, here we go. So this shows, so there's a technology called focus diverse phase retrieval. And they're able to, this is basically a measurement of the wavefront of the instruments. And you can see this is, that's the spot where the meteorite hit. This is the wavefront of the telescope, excuse me. And so this shows where that meteorite hit. And, it has some effect, but it's not a ground, not that big of a deal.
Other questions? Anybody online?
And you'll see, you might notice if you see if I can click on that. You can kind of see how this mirror has more wiggles in it, right? That mirror and this mirror and actually this one, all three of these, they put them behind these struts because those were some of the worst.
Oh.
Those mirrors had manufacturing defects. They built them to the slightly wrong radius of curvature. And when they actuate the radius of curvature actuator to correct it, it leaves a little bit of a 6-spoke pattern.
They said just diffract them. That's funny. That's funny. That's funny. Any more questions?
The woman imager, how did she come to be the imager to do these images? Did she just all of a sudden start taking the data and sending it?
I don't know, he has her picture. I didn't show, I was worried I was going to go over. So here she is.
Judy Schmidt of Modesto, California. She processes images. And for example, here's one and creates, some beautiful stuff and just does it. I don't think she gets, who knows, maybe she's got a web page that she makes some money on or something, but I don't think she's not getting paid by NASA. Let's put it that way.
Oh, wow. Pretty cool.
Here were some of the pages I didn't, so in the Tarantula Nebula, they found 10,000 new stars in there that I hadn't seen before. Yeah.
Pretty amazing. Pretty amazing. Well, Conrad, thank you so much. Appreciate your doing this for us today. We got learned a lot of information, a lot more in depth about the James Webb.
I lost audio.
Oh, awesome. You hear me? No.
What's going on? Oh, I went to here. Okay, I got you, I think.
Okay, you back? You hear us now?
Can
you hear me now?
Yeah, I got you. Yeah.
Okay. I'm saying thank you so much for doing this for us.
Okay.
It's a lot of great.
Great. That was fun.
Oh.
Yeah, I'm glad, it was John made it easy for me with those great images and some of those animations. I really like that. And then again, you look on these are actually just images he took right from, the web pages, right? But he adds a little context to it. And there were some notes in, he gave me some hints in here in his notes to help. So, well, thank you so much.
Well, thanks. If you're ever in the Rochester area.
Okay. Sounds good. Thank you.
We'd love to have you come visit again. If you're ever decide to come back to Rochester even for a visit, glad to have you.
Well, I do need to visit my friends at some point.
Yes. Thanks, Conrad. Have a good night.
Thank you. Bye-bye.
Oh, let me do this. Move this back over here. Share this screen. Hang on. Move this back. I'm all over the place here. Bear with me. Move this back over here. And then I forgot something. I forgot something before we did this. Forgot to talk about the Ionia Fall Festival. So Vicky, you want to come up here so everybody can see you? That's right. I don't want to leave you in the lurch here. So come stand by where I'm standing so that everybody online can see you. We'll talk about the Fall Festival.
So,
Over here. Come over here. Stand over here so people online can see you too. You're missing the cutoff jeans.
yes, cut off jeans. So I'm dressed like this to inspire everyone to come out to the Ionia Fall Festival and Tractor Parade and help out. I usually do it every year, but unfortunately this year I have other plans, so I can't. But I'm hoping that some members like show up and have a good time with it like I do every year. It's a great opportunity to start the fall season. I usually buy some mums and a pumpkin and maybe some corn stalks, and they've got like a big barbecue that is great and a wheel of desserts. There's some other crazy thing, and there's other stuff like you throw pennies into old-fashioned teacups. So it's filled with all this homespun fun, and it's usually music. And this is where we kind of like partner with the festival, and the hayride stops right near our booth, and everybody jumps on the hayride, and we bring them on up here to the site, and we give tours. So we work hand in hand with the Fall Festival folks, and then every year at like, is it 1 o'clock?
Yes, 1 o'clock.
1 o'clock is the tractor parade, and there's usually between like 70 and 139 tractors in the parade, which is super fun. You know, and they've got kids riding them, grandpas, dads, you know, brothers, sisters, moms, everybody, and some are antique and some are new. So it's super fun, and it's just another way that you can support the club and just kind of have fun with all the things we do. Like, I also do the winter festival at Mendon Ponds Park, and I'm hoping that we have it this year. And Don usually helps me with that, and they usually get some visitors that stay for a while. And that's kind of what we're looking for, is just pop in, say hi, maybe give whoever's at the desk like an opportunity to get up, maybe use the restroom, get something to eat or buy something. And then you get to sit down and talk to whoever pops over to the table all about astronomy. We'll have a sign-in sheet for visitors, so they can leave us their email address, and we're going to be sending them out a like abbreviated version of our newsletter to like generate interest, and hopefully we'll see some of those people at one of our meetings. So that being said, I hope you guys definitely come on down. They have like a donuts and coffee. They have donuts and coffee early in the morning, and we usually come for that. They used to have pancake breakfast. That was really fun. It was a good way to kick it off.
Well, it's coffee and donuts, I think. In the morning now.
Yeah, now it's coffee and donuts.
But the lunch is good. There actually is a sign up sheet here, and if you're online and you're interested, say something in the chat.
Yes.
Be glad to have you there as well.
Right.
So we'll
So
save that.
hopefully everybody come on down and have fun. And it'll be great. And maybe I'll see you.
Can I borrow that shirt? No, I'm
Volunteer
kidding.
with me. Yeah, this is my.
It's your farmer shirt.
country
It's your
my
farmer
farm
shirt.
But, you know, maybe if not this time, since I won't be here, but I will be, of course, I'm hoping I will be here for the Winter Fest, and I'm hoping we have it. So.
Awesome.
Awesome.
Thanks, Vic.
Thank you.
All right. All right. Unless there's anything else that we need to talk about, that's going to be our meeting. Anybody online have anything else we need to address?
Anybody want to sign up online?
You want to sign up online? Let me know. So I want to say thank you to everybody. Great September meeting. I think it's clear outside. So we're going to go do some observing and wander around here at the Fair Center. Thanks, everybody, for coming online. We'll call it an evening here.
Oh,